Hi, this video is about moles. It's for honors chemistry. Um, we're going to be looking at and learning now. This is where I think things will be pretty new for you. We're going to talk about something called molar mass, and then we're going to be able to do calculations with moles. So you guys watched the video, what is a mole? Or how big is a mole, I think it's called. But anyways, so mole is a chemistry it's actually the SI or metric system unit for counting the amount of something. It's weird. It's a big number, but it is similar to like a dozen. So a dozen is 12, whether that's a dozen flowers, a dozen cars, a dozen airplanes. It doesn't matter what you're counting. So 1 mole is new to us, is 6.022 times 10 to the 23rd cars, pencils, flowers, whatever. But because it's such a big number, I think they made it pretty clear in the video that you would never use it for something like that, but you would use it to count atoms, molecules, ions, formula units. That's just what we call like an ionic compound. We'll get to that later. But so it's something that is a really important part of chemistry. So you should ask your parents, even if they're not in, scientific STEM field, if they remember what a mole is, because they will. If you've ever taken chemistry, it's not something you ever get away from. So Avogadro, we saw the video, poor Avogadro, but they did name the number after him. So sometimes instead of saying 6.022 10 to the 23rd, people will say Avogadro's number. So it's just something that you'll hear like terminology wise. And here is, like I was saying, it is the SI or metric unit. And in science we use metric. You'll see more and more as we do more. And so the way that we use the mole is for right now, we're just going to say for an element. So an element on the periodic table, 1 mole of carbon, let's say, is going to have 6.022 10 to the 23rd atoms of carbon. And I can do that for any element on the periodic table. 1 mole of gold would be 6.022 10 to the 23rd atoms of gold. There's another thing on the periodic table. You remember how we have the average atomic mass down here? And when we learned about atomic structure, we know that that isn't the same as the mass number. This is really a weighted average of all the different types of carbon. There's 3 types of carbon 14, 13, and 12. And we're not going to get into how to calculate that, but anyways, the cool thing is, and again, I'm not getting into the math behind this, but it's all based on math and other experiments with gases. But the average atomic mass is what we call the molar mass. So now if I said, hey, you can't, get your passing grade in chemistry unless you get me a mole of aluminum, you would go and find aluminum on the periodic table. If you guys have your periodic table out, you could look. I shouldn't have done aluminum because I don't have a visual, but I do actually know the molar masses of a lot of elements by heart. So 1 mole of aluminum, I said, you have to get this for me or you can't leave the building. It's so important. Then you would go to my storeroom, you'd grab some aluminum, and you would get a balance, and you would mass out 26.98 grams. And at school, I do have mole samples to show you that these are, I'll show it to you during the Zoom time, but they're amounts that we can see and we can hand to each other because there's so many particles in them. The molar mass is measured in AMUs. The average atomic mass is AMUs, but when we use molar mass, it's that many grams now. So this would be grams in 1 mole. So I'll just kind of show you some more examples. So like if I do at school have a mole of iron, because it's cheap. I don't have a mole of gold or silver. That would be great. But anyways, a mole of iron. So I would find it on the periodic table, and this is the average atomic mass. So I would know that the molar mass of iron is 55.85. Sometimes, like if I just ask you what the molar mass is, you would say 55.85 grams per mole, because there's that many grams in 1 mole. Another way is to write an equality. Like for the silver, it's 107.87. There's that many grams in 1 mole. And gold is 196.97 grams in a mole, or we could have said the molar mass of gold is 196.97 grams per mole. So kind of a little bit, maybe too much here, but here's another example. Hydrogen on your periodic table, everything goes, I think, pretty much to the hundredths. So 1 mole of hydrogen would be 1.01 grams. 1 mole of lithium is 6.94 grams. And then 1 mole of sodium is 22.99 grams. If you have your mole map now, I want to show you some things that I want you to label on it. We're only going to use this top part here for now, but eventually we'll use this whole thing. It's just a tool to kind of help us wrap our head around these kind of problems. Some of you won't need it, and then some of you will. So in the beginning, I just want you all to give it a try. So here's what I'm saying. So if I have the number of atoms of something and I want to convert that to moles, I'm going to use Avogadro's number. Okay, so I made this a little bigger so I can write on it better. So when you're converting, let's say I want to go from mole to the atom. So let's say I've got 5 moles of copper. How many atoms would that be? I'm going to use Avogadro's number, 6.022 times 10 to the 23rd atoms in 1 mole. So I'll show you how to use this in just a second, but that would be our conversion factor. If I was going to convert, let's say I know that I have 3.5 times 10 to the 24th atoms of copper, I would then be able to figure out how many moles I have. So in this case, when I take the green route, I would put 1 mole on the top and Avogadro on the bottom. There's also, and again, this will make more sense once we get into the calculations, but for now, just label it. If I know I have, let's say 6 moles of silver, I'm going to use the molar mass of silver, and I'm going to leave this like a circle, because that'll vary. I'm going to look that up on the periodic table. There's that many grams in 1 mole. And then if I'm going, I want to use a different color, but I don't know if I can. Oh, are there different colors here? Yes. Okay, give me a second. Okay, sorry, I know you guys can fast forward me too. When you go this way, you're going to put 1 mole on the top, and then whatever the molar mass is, I'm leaving a circle because you'd fill that number in grams on the bottom. So this will make a lot more sense once we start to do the calculations, but I want you to have that filled out in front of you. So here is our first example, and we're being asked, what I know that, let's say I know I have 3.5 moles of copper, and I want to know how many grams that is. So I would look on the periodic table, and I know you have yours somewhere, and I don't have a visual right now, sorry, but I know this is weird. I think it's 63 point, I gotta grab mine. Is it? Copper, where are you, copper? Yes, 63.55 grams per mole. So I looked up the molar mass, that's my first step. My next step, I'm going to actually take that, even though it's not the way I wrote it here. I'm going to take this beginning number, just like we did with dimensional analysis with like metric conversions or anything that we were doing. I'm going to start with that number, so 3.50 moles. I'm going to put copper there. It's a good habit to get into to actually put what it is. If you don't, I wouldn't take points off. But you'll see as we build and build with these types of problems that it's really helpful to keep track of which element we're talking about. Then I would put, 1 mole of copper has 63.55 grams of copper in it. So this is over 1. If you want to continue that, it's up to you. So then I would just take 3.50 times 63.55. My calculator is going to say something like 222.425 grams, but I'm going to round with sig figs. So I have 3 sig figs in my beginning number, and we're multiplying and dividing. These have infinite, so we ignore them, sig figs. So I want to have 3 in my answer. So I can't even read my own writing. It's there's a decimal there. It's going to be 222 grams of copper. So now we can go the other direction too. So I'm going to, whoops, this should be aluminum. I'm going to look up aluminum's molar mass, and aluminum, 1 mole of aluminum is 26.98 grams of aluminum. And I'm going to use the mole map. I forgot to last time, I'm sorry. So the chemists produced 11.9 grams of aluminum. So I'm going to start with that number over 1 or not, doesn't matter. So I'm really starting here, and then I'm going to go to moles. So I'm going that way. And when I go that way, I want to put 1 mole on the top and the 26.98 grams on the bottom, because then my grams cancel and I end up with mole. And with 3 sig figs, because I have 3 here, I'm going to get 0.441 mole of aluminum. So now we're going to use some conversions with Avogadro's number. So you get to hear my dogs. So in this question, they want to know how many moles. So I'm trying to get here, and I'm starting with atoms. So I'm starting here. So I'm going to write out my beginning number always first. So I have that many atoms of silver, and I want to know moles. So I'm coming this direction in the red. So I know that there's 6.022 10 to the 23rd atoms of silver or anything in 1 mole of anything. So I'm going to put Avogadro's number down here. In 1 mole. And now you can see my atoms cancel and I'm in moles. I'm going to pause the video 1 second, and then I'm going to grab a calculator and show you something. So I wanted to show you how to get the answer with this number. When you have something with scientific notation in the denominator, you need to put it in parentheses to get that power of 10 to kind of stick with the beginning number. And I wanted just to show you a trick that we're going to use a lot of numbers like this in chemistry. If you have a calculator, what you do is I'm going to take that beginning number, the 3.01, and instead of writing times 10 to the with the little caret key, I'm going to go second, and you see the little EE? That is the power. So I'm going to put in to the 23rd. So that when I write it that way, it's the same as 3.01 times 10 to the 23rd. And then I'm going to times it by 1, which I don't need to do, and then I'm going to divide by Avogadro. So 6.022